start the recording. So. All right. So good morning to our U.S. colleagues, and I guess we've got good afternoon to our East Coast colleagues, and then good evening to our India colleagues. Today for our UI Assist webinar, we're very fortunate to have Mr. A.K. Saxena, who is currently heads the Electricity and Fuels Division of the Energy and Resources Institute, or TERI. He has over 40 years of experience in the power sector in India, and he has worked with the Central Electricity Authority, the Ministry of Power, and the Central Electricity Regulatory Commission. After retiring from the government, he is with TERI, where he works on various projects and has been one of our key leaders related to some of our field demonstrations that he will be talking about today. So we are excited to have Mr. Saxena here, and so I won't take any more of his time, and we'll turn it over to him to talk about the urban pilots and an overview. And as I mentioned earlier, for those that may have just joined, is one of our goals today is to see if there are opportunities for us to interact. And so from there, we see if there's an opportunity to interact in our last 6 months of our UI Assist project, but also and beyond, because obviously these demos and these field demos will have some great work related to data available in the future. So Mr. Saxena.
Thank you so much. Thank you, Professor Noel. It's such a pleasure to be with you all. And I think my forte is slightly different. I'm more on the policy and regulatory side and having the different type of experience. But it has been a very good learning for me in the UISS project, with a close interaction with all of you and a lot of experts from the IITs. That's a pleasure, without any doubt. So I'll be touching in general, in principle, what we have gone about. Now, these are as we all know, the colleagues, basically, we are all from the UI Assist family who are attending it today. And this project had certain pilots. Demonstration was an important component of the project. And there are rural pilots and urban pilots. Today, I'm going to talk about the urban pilots, which have been done in the license area of BSES Rajdhani, which is a electricity distribution company which supplies electricity to the southern part of Delhi or South Delhi. Now, on the next slide, what we will look at is what is the objective of these urban pilots, and primarily these pilots were designed to find out what is the use of these battery energy storage systems for various applications in the electricity distribution network. And some of the applications which were sort of zeroed on were overload management and peak shaving at the distribution transformer feeder level by integration of battery energy storage system. The distribution transformers, when the loading exceeds beyond a certain limit, then the utility starts thinking about the augmentation of the capacity if possible. That is what is the main issue which comes about. But what is seen about that the overloading of the distribution transformer is there is to start with, sort of for a certain period of time, which is not very substantial. And then one could really see about whether it is possible to defer that investment, additional investment, whatever is required. So maybe the battery energy storage system meets that requirement of that energy which is beyond the threshold level, and thereafter one can make use of it to the extent it is possible. So that is the primary application which was thought about for the DT feeder level overload management, DT overload management. Secondly, I think the other part was that certainly when the peak uh, loading is beyond a limit and the supply is being given by the battery energy storage system, then I think the peak reduction is there, that then it is also possible that whatever is the peak time energy usage is there, one can shift it to the off peak time, and then in the peak time one can supply from the battery. Energy arbitrage is another application which we will talk about later in detail. And in order to perform whatever is duties required to be performed by the battery energy storage system for various applications, the energy management system which is associated with these, what is the control logic which has to be designed for this. So primarily I will cover these aspects in this. So when we go on to the next slide, we see that the we have tried to capture the approach and methodology which we try to follow in this. So first of all, we I mentioned about some of the applications earlier, but we looked at various applications in consultation with the distribution company in the BSES Rajdhani, and then tried to see that what are different consumer categories where we can try to see the possible use of these storage systems. And after looking at that, the preliminary site selection was there, whether it is feasible to put that or not. That is what is the first requirement. So in order to arrive at the plausible application, one had to look at the what is the load or what is the load profile, what is there, and then whether that site which we are trying to zero on and whether that has the sort of a place to put these systems physically or not. And then the control algorithm was to be designed for the primary application. But when we did the primary application, which we'll see in the next slides, that it looked like that somewhere it may be possible, it may be the situation that the primary applications do not justify the cost effectiveness of these. So maybe one has to look at the secondary applications also. Before going into all this, that the actual sort of a system design and procurement, the modeling was done on MATLAB, and then it tried to see that what best is possible to get that from the modeling before the designing of the system and awarding it. Now, the secondary application also I'll mention about it, that what we have identified for the 2, 3 sites, and then we will look at the various applications. And now the current state of affairs is that all that has been done and the contract was after the specifications way contract was awarded and the sites are under implementation. Two of the sites are sort of a pretty in the advanced stage, but for one, the remote connectivity, that is the system which is there at the discom end, and it has to be connected to the TERI headquarter for monitoring purposes and also to the BRPL SCADA center for better monitoring and control. Now that part is sort of in the last leg, but when one of the sites, I think because of the change of location, there is a delay and I think it will take a few more months to complete that. Now coming on to the next slide where we will look at the what are the sites and what are their details. So the actually, we chose the three types of consumer categories. One is a residential category, second is a group housing society, and third is an institutional consumer, which is our TERI School of Advanced Studies. Now, just getting some interruption. Yeah. Okay. Now the specifications of these three locations are given, and the resident and in the residential category, which is there. This is a feed distribution transformer of 990 kVA, and it serves about 80 multi-story houses. The maximum loading when the project was initiated in 2017, it was 65%, but it was expected that in 2023 it will go to about 90% for 4 to 6 months. That was the baseline study, and it was thought about that energy arbitrage could be the sort of a main application. Now, when we look at the category B, the group housing society, therein we were a diesel generator set was being used, 320 kVA diesel generator set, which was for providing backup for the critical loads. And society was also having a 120 kilowatt of solar panels. Now the DT which is there is 630 kVA, then it serves about 195 households. It's a multi-story building with a lift and other critical load, which we'll enumerate in the next slide. The third category, which is institutional category, 1600 kVA DT is there, and then it has the feature that this campus has the time of the day tariff, where from May to September in the year, there is a during the peak load hours, they have to pay 20% extra tariff, and during the off-peak hours, which are sort of a lean hours in terms of demand, then they have to be paying a discounted tariff at a 20% of the base price. Let us say the base tariff is 8 rupees. So during the peak demand hours, they will have to pay 9 rupees 60 paisa. And in the lean demand hours, they will have to pay 6 rupees 40 paisa per kilowatt hour. So that was the purpose here to see about that. How can we try to see that battery energy storage systems try to make use when the peak time tariff is being sort of attracted by the utility or the consumer, I should say, then how could they try to reduce that with the help of using the battery energy storage systems for the supply during those hours. Going on to the next slide, what we look at is certain other sort of features which are there. And if we look at this slide gives you the what are the applications which are there. The primary application in the residential society is on the DT overload management, and the secondary one was the energy arbitrage. And the usable capacity here was 230 kilowatt hour. There are four racks or stacks of 72 kilowatt hour each. And interestingly, when we did the sort of a battery chemistry selection, all the three locations, the iron phosphate batteries were sort of found to be most suitable for this. And then when we look at the category B group housing society, I think the primary application, I'll repeat that it was the backup power for the critical load, and secondary application here also was energy arbitrage. Here the usable energy was about 120 kilowatt hour, and the design capacity is given at three. There are three racks or stacks of 72 kilowatt hour each. The energy time shift, I talked about the institutional category of consumers, and then the secondary application was that where because there is a solar PV available there, can we use the solar PV to be using it as a virtual power plant? The usable capacity energy in terms of this is 60 kilowatt hour, and then there is only one stack of 72 kilowatt hour. These are the sort of features which are there. Going on to the next slide, what we try to find out is that what is given there is the benefits. So I think I spoke initially also that can there be a investment deferral in the distribution transformer? That was one of the benefit which was we were trying to look at. Then saving in the peak power purchase, certainly the reliable improvement if the distribution transformer overloading gets reduced, then certainly the sort of a life of DT improves, and the interruptions in the supply which are likely to be there because of the DT overloading will not be there or may be mitigated, then the reliability improvement is there. And the DT life could also increase on account of better utilization of the asset. The group housing society, the benefit which was there, the reliability improvement in terms of the fact that in Delhi, in the winters, there it's heavily polluted, and there is sort of a regulation by the government that the diesel generator sets cannot be used. In that situation, such battery energy storage systems are extremely helpful because then the critical loads can be supplied by these systems. Then the diesel consumption, certainly it will be reduced and saving would be there. So electricity bill savings will be there, and certainly there is a reduction in emissions. That is a co-benefit of such a intervention or a measure. Category C, savings in power purchase cost because they will not have to pay for the peak time tariff, which is 20% more. So that is what the batteries can supply during that period of time. And the solar power, which is there, if they have the excess of generation and they can inject into the grid, then certainly I think they get to make better use of that solar generation. Going on to the next slide, which would talk about the schematic details. So this diagram shows that the connectivity which is there, starting from the left hand side, the grid substation, then there is a distribution transformer, then all the metering, the panel, the AC/DB, then comes the power conditioning system and the battery rack. And then the energy management system is there. And then there is a remote connectivity. Left hand side bottom is the remote monitoring at the TERI headquarter. On the right hand side, it is the remote monitoring at the BRPL SCADA center. What is there? So this shows basically the schematic for category A, the residential society, residential consumers, not the society being supplied from that. In the next slide, we will look at the logic which is there. The control logic, what is there is now the battery which is there about 230 kilowatt hour, that was identified as the best possible or appropriate size of battery with the loading which was expected on the DT. And the now the logic which is shown on the right hand side is that suppose the DT loading for the practical purposes is 990 kVA DT. Let's say we take it as 100 to 1000 kVA DT, then the 80% of DT loading that becomes 800 kVA. So whenever the DT loading becomes more than that 80% threshold level, then the DT becomes overloaded, and at that point of time we have to be discharging the batteries or supplying the power through the battery energy storage systems. And on the right hand limb, when we see when we supply through these battery systems, and then we try to see what is the state of charge available in the batteries, and when it is greater than 15%, then yes, we the logic allows the discharge or the supply through the batteries. And if it is less than 15%, then battery remains in the idle mode. Whenever the loading is less than the threshold loading, then the charging of battery takes place. And naturally, when the charging is to be done, when the state of charge requires it to be charged, otherwise it remains in the idle mode. So this is what is the basic control logic. We have tried to give a very simplified diagram. Now on the left hand side, you see that the control logic, whatever was sort of explained, that has been sort of put into the system. And then the in-house modular development of modular EMS has been developed by the vendor, and it is embedded with the distributed controllers of the system. And this is now one aspect which I would like to cover here is that when do we do this discharge or supply from the batteries? That is, our colleagues have done some sort of a assessment of the day ahead DT loading based on the AI and ML techniques. And suppose there are going to be two peaks, a morning peak and an evening peak, or two peaks with slightly different timing. So whichever peak is going to be more severe, only at that point of time this battery discharge is going to be done, not for the other peak. So that is what is the idea being that we should try to cater to the situation where the demand is more severe and the DT overloading is going to be more critical. So this is what is the basic control logic of the category A consumers. We go on to the next slide. We find out that the next slide, please. Now, this is the energy arbitrage application, wherein what we have tried to see that the key electrical parameters of the battery will be monitored, and then battery, the state of charge and the DT loading, it is to be monitored, and then we try to see whether this is a peak time or it is off peak time. Peak time here means that the when the tariff is going to be high, then certainly the discharge is to be done through the batteries. And then when we do the discharge, we always the idea is to look at the state of charge which is there. The state of charge, if it is good, then the charging is done based on the power and the battery voltage, what is written in equation 1 at the right hand side. And if the state of charge is sort of a not good, then the battery remains in the idle mode. Now on the left hand limb, when it is charge mode is defined, so it is not a peak time from the loading consideration. Then we try to see this off peak time is slightly, it is written on the left hand side with a star mark. This is the time when the whether the discounted tariff is applicable for that time block. That is what is more appropriate to say. but in the short time which was there, we could not modify the diagram and make it correct. Now, whenever the discounted tariff is available, then when the state of charge, depending on the state of charge, I think the charging is done either in the constant voltage mode or in the constant current mode. And appropriately, the equations which are given down below, they sort of show that what is the rate at which it is done about, what is the current equations. Then we go on to the next slide. We find out that this is the schematic for category B. Category means the B was the apartments with the diesel generator set, and in this schematic you will see almost everything is same. But for if you start looking from the top left, then the from the distribution transformer there is a diesel generator set, and rest of the system primarily remains same. There's hardly any difference on that account. Then we go on to the next slide. We see that what is shown there is the control logic, and this is a 320 kVA DG set which operated at about 50 to 60% of the loading when the sort of a project was initiated. And at that point of time, the power cut was about for 2 to 3 hours a month. And then the common load, critical load, which was on the elevator, street light, corridors, water pump, and firehouse pump, they all put together was of the order of 200 kilowatt hour. Now, the logic which is shown on the right hand side is that whenever there is a power outage, then the on the left hand side limb, the supply is to be made through the batteries, and depending on the state of charge, if it is either the battery will remain in the idle mode or the other or this will be discharging. Now, on in the discharge mode, there is another condition what we have tried to see about, because this our common load was about 200 kilowatt. So to be on the safer side, I think we have tried to see that 240 kilowatt sort of a limit was there, and if it is less than 240 kilowatt, then we will discharge through the battery. If the load happens to be more than 240 kilowatt, we would start the diesel generator set. Here, one important component is there that there are 192 flats in this complex, and every flat has about 1 kVA which load which is supplied through the diesel generator set. So if we put that also, there is a possibility that the load may go beyond the limit, and then that is why this second decision box has been there, that if the load exceeds a certain limit, then I think one has to go on to the diesel generator set rather than sort of going through the battery supply. Next slide, I think, which shows something on to the secondary application of the category pilot. Again, it is again the depending on the time of the day tariff. So if we look at the decision box, whether it is peak time or off peak time, so then the charge or discharge has to be there, and then the one has to look at the state of charge while discharging. If it is sort of a healthy enough to be supplying, then I think it is discharged. And if it is not, then it remains in the idle mode. On the other side, if you again look at it, again it is dependent on the tariff, whether we are going on to the discounted tariff or the sort of a other tariff, then the charging is done on the constant charge mode or the constant voltage mode, depending on the level which is required to be reached from the current level of charge. On the next diagram, when we go, we can see that we have the schematic for the this is done. I think we have to go to now the next one. Is this? Yeah, so in the category C, the schematic now here, this is the institutional consumer, wherein apart from other things on the left hand side, there is a solar PV system there, and all that the from the substation, the transformer, the meters, the panels, all other things remain same. And then I think this is what is the schematic here. And now when we go on to the next slide, we try to see that what is the control logic here? I think again, this is all if you the basic features are given that if you see on the right hand side, what is written is there are 3 time slots. Then 1400 to 1700 hours and 2200 to 0100 hours. This is the peak time tariff where additional 20% tariff becomes applicable. And then there's the morning 4 a.m. till 10 a.m. This is the discounted tariff which will be available. And this time of the day tariff is sort of applicable in Delhi for these category of consumers from May to September every year. So depending on the, I think the logic again here remains same, that depending on the time slot of the tariff, applicable tariff, that whether the batteries will supply or batteries will get charged. And herein again, I think the basic parameters remain the state of charge, and that is what it is. Now, if there is any other slide, we go on to what is there on category C. Next slide. Now, I think these are all the photographs, pictures which have been taken when the project monitoring committee visited this. The left hand side top is the category C site. And I think this is what are the conference room of TERI or on the right hand side. Similarly, the project monitoring committee is at some other location. I cannot make out which location it is. I think it is category A, Taimur Nagar side. So that is what it is. We go on to the next if there is anything, or it's now after the commissioning, I think which is likely to happen at least for two categories, the category A and category C, hopefully within a month or 1.5 months. I think the cyber security audit of the pilots is contemplated. And the next step or the other point which we have in mind is that whatever data comes after these systems are put in place and they are commissioned, and then we will try to see that is there any further optimizations required to be done in these systems on the fine tuning of parameters or system model, and then the impact evaluation. Now, one point I would like to mention herein is that in a urban setup, the DT overload is something that is what is common, and one can still find out that the requirement will be there. But in the diesel generator sets wherever they are being used in the residential society, etc. Now the power supply being pretty good, the outages are not that much. And on account of that, the cost effectiveness of these systems is really a big question. So these projects could be, as the objective was more to look into the sort of put up the demonstration plan, which sort of set up the confidence and credibility in these systems to supply critical loads, etc., rather than being commercially sort of viable at this point of time. So that is what is one aspect which needs a mention. Rest, I think things can sort of we will draw the learning more when we get the commissioning done. Uh, that is what it is. So I think this is all I thought I could cover about it, and maybe the questions are welcome. And if there is anything which I could answer, or maybe our colleagues are also there, if there is some detail which they could furnish, that will be very good to talk about. Ahmed, there's some question.
Yes, so there's one question that's here. Are the slabs in the electricity price tariff on top of the time of use for industrial customers?
Yeah, they are for industrial consumers or HT consumers, and that is what it is. It is in Delhi and a number of states, it is like that. So I told that there are the peaked wherever the peak demand for electricity is there. So in Delhi, the 20% higher tariff is charged, and when there is a lean time, there 20% discount is there, and rest of the day it is the base price.
Okay.
Yeah,
That's the
Ahmed,
only question we had in
yeah,
the chat. Are there other
yeah.
questions?
Hi, Noel. Yeah,
Yeah, go ahead,
can
Ahmed.
just want to
Yeah,
know. So,
please.
Saxena ji, yeah, that's a very, very good presentation and is very informative. But just I want to know your connection in the DT, this primary side or secondary side? for the battery?
Is secondary side. Secondary side.
Okay. So why do you, but if you use primary side, is it not good, or is there any logic that the why secondary side? Because secondary side voltage is low, and then your current will be very, very high.
Can somebody from our team tell that whether I'm telling what is correct, or Mukesh, are you there?
Yes, sir. Because our main purpose is for the peak saving application. So after the secondary side battery storage system, we can analyze how many load are there, and based on that, for the secondary load there, secondary side.
Okay.
So, Mr. Ahmed, do you suggest that there would be any advantage if we try to look at from the primary side the purpose what we have in mind and the objective of the pilot which is there? Your suggestion is welcome. Be happy to sort of understand a bit more.
No, the main advantage, if it is primary side, then yes, current will be low, and then maybe loss will be
that's
low.
right. That is right. Yeah.
And the cable side will be low, but yeah, but yeah, we also consider other thing as well. But okay, I understand. So it is the secondary side. Secondly is the inverter. So you use inverter, the 4-coordinate inverter, or the single charger and inverter?
I would not know those details. Somebody will have to tell. Mukesh or Praveer, anybody? I don't have those details with me.
So inverter, I think, is 4-coordinate inverters. We can also provide the DC power support and all those things.
So you have reactive power, right? Support.
Yes, we can provide, but currently we did not control it from the EMS side.
Okay. But and the same question, for the EMS, you have the primary control itself, or you have the SCADA. You can, let's say, when it is charge discharge. I saw the logic. Let's say
it will be. Yeah. It will be controlled from the SCADA center of the utility. So from the utility, we can set the charging and discharging threshold based on the loading. The EMS will automatically give the command to the battery energy storage system, and based on the loading, it will be charged and discharged automatically.
Okay, but you don't have any energy management system or the BMS with inside the battery. So if let's say there is
inside,
no, yeah, if there
likewise
is no
there are,
connection, yeah,
likewise there are BMS and the central GBMS is there, and for the whole system we have the EMS also, energy management system.
So can you control those things from the EMS, the built-in EMS primary? If I don't have any SCADA system, let's say I have a very let's say for the building, so the SCADA system you said that is implemented in somewhere TERI. So the building guys, they give you permission to handle for those building or those commercial place, because they should have their own, right? You guys control, or utility control from outside of their battery.
We can also control from our TERI headquarters, but this is not permissible. So we have only monitoring permission only. So we have restricted to the monitoring for our TERI headquarters, and from BRPL SCADA center we can monitor and control both.
Okay.
Ahmed, because the utility being the sort of a owner of the assets and the system, so the BSES Rajdhani, the distribution company, only is the right agency to be having the control option. We at TERI can only monitor it for the purpose of getting the required data to be able to do analysis and do further sort of if anything, whenever we move forward, what learning we can draw from that data.
Because throughout the project life, we will provide the input the utility. So based on the which loading the systems should charge and discharge. So we will provide input the utility, and based on our input, utility will give the command to the system.
Okay, good. Okay, thank you.
So I think one question which Professor Noel mentioned, Professor Noel mentioned in the morning, in the beginning was that is there anything we can sort of try to take forward, do anything forward? Is there any suggestion on that account? That will be really good to understand.
Yeah, same
If
thing
there's
I can add.
anything.
One more thing, that is the can
Yeah.
you use for both purpose? I saw here, let's say you have used for one, right? Let's say energy arbitrage or something.
Yeah,
Can
yeah.
you use for those things for more than one purpose? Because you already mentioned that sometimes it is very hard to justify that the let's say only for our energy arbitrage may not be justifiable for let's say $1 million for this amount. I don't know how much we save. So can you use for
Absolutely.
both purpose or couple of purposes?
So that's why.
Yes.
So that's why, sir, we have designed primary and secondary application both. So because peak saving is only occurs in summer months, maybe 4 to 6 months. So the rest of the month, the battery will be operating in the secondary application like energy arbitrage or like that. So we are utilizing the battery energy storage system throughout the year.
But same time multiple purpose. Can you do that?
For the same day.
Yeah, same day. Whichever come
So
first. Yeah.
actually, we have restricted 1 cycle per day. So based on the 1 cycle per day, our demand. So vendor have given our number of cycles based in the battery, 4,000 cycles. So if we consume that before that, so it will be we can use 2 cycle per day, but we have restricted it to 1 cycle per day.
Thank you.
Yeah, the cost effectiveness, Ahmad, is the most important point. I think that is what is going to be the challenge, the type of costs which are available today. So I think whatever best can be done to bundle the application, that is possible. But right now the design has been to use one application at a time and do the 1 cycle per day. But this is a question one can look at, that how can one do it at later stage.
Yes, sir, this is just for keeping the battery health.
Yeah, that's what it is.
Hello, Mahesh here. Can I ask question?
Yeah, Professor Mahesh, yes.
How are you, sir?
Yeah, first class.
I just wanted to know that when you operate the inverter, do you monitor the health of the grid, the voltage and frequency, and then the action is taken, or it is not monitored, just it is based on some other parameters?
I think Mukesh, you reply. Mukesh, can you tell him what is?
Sir, we are monitoring the DT loading. We have installed the meter at the secondary side of the DT. So we are monitoring active power, reactive power at the secondary side. So based on the loading, the PCM application will be run.
My question is that, see, when you connect the grid, this inverter to the grid, because you are because you are sharing the energy between the grid and your storage as well as whatever the renewable energies are there. Okay. So when you take care of grid, then the grid frequency and voltage has to be monitored, and that frequency and voltage has to be within some range. Otherwise, we have to make it a standard mode. So do you?
Yes, so we are.
Yeah.
Yes, sir, we are monitoring. Yes, yes, sir.
So what is the frequency and voltage limits you have considered in this operation? Let us say 10% plus minus voltage or frequency, maybe something around, let us say 1% or something like that. Are there these, they're well defined in your program, or you have taken from some standard? I want to know more details about that.
Actually, sir, I think for the standard. So we are limited. I did not remember. But in the EMS, we can see all the parameter in the EMS, like what is the frequency is there, what is the voltage level, and all those things. If anything parameter is not there, you must solve the alarm.
Okay, so alarm, suppose voltage goes below 10%, then what will you do? After alarm, you will take off from the grid? Inverter operation?
I think Professor Mahesh, Mukesh, are you able to tell me, or otherwise we can look into what is the limit and then come back to him.
No issue.
I will check and we will let you know, sir.
Yeah. This is an important point.
Thank you.
Okay, there's a question in the chat. Is there any specific definition you have used for the battery cycles?
Mukesh, would you like to answer?
The question is about that how many how we are calculating the number of cycles. Sabir sir, can you explain? Like number of the cycle, how we are consuming or calculating.
Yeah, that is true. Actually, I was wondering that in a typical day, so there are multiple ways in which you can define how many number of cycles. There are definitions of state of the health of the battery, state of the charge of the battery. And then typically when you talk about the cycling of the battery, then that means that you basically have to charge it completely and then discharge it completely. But in a day-to-day operation, that may not be the case always. So so there could be partial charging and partial discharging. So
Yeah,
my question is that
yes.
how do you define the cycles? Because
So
while doing
So I understand your question. So we have discussed with our vendor, with the battery provider. So in the BMS, the algorithm likes us that if we partially charging the battery, so let's say if we use 50% capacity in one cycle and 50% use capacity in the next cycle, so that will not be the two cycle. That will consider the one cycle. So based on the capacity, it will how much capacity we are utilizing. So the number of counting of the cycle will be accordingly defined.
So whenever it means that whenever the full discharge has taken place, then it becomes one cycle.
Yes.
Okay.
I get it.
Professor Mahesh, you have another question? Hand is up.
So I think one of the broader questions is what is the opportunity for us to look at what data you all have? How could we compartmentalize? And we talked about that earlier with some of the UISys leadership. How do we take some of the information, data, real-time data that you have, and look at using that, putting that in a way that some of our partners, both, particularly on the US side, might use that to look at algorithms they develop, to look at models they've developed, all those kind of things. I mean, how do you see as your different field demonstrations are up there, it's providing real-time data, real-time degradation, real-time, how you're using that, the controls algorithms. We have several different projects that have looked at control algorithms, volt-var control. So is there a way we might be able to take some of your data and work together to kind of do some experiments on that?
Insofar as the once the pilots are commissioned, I think it should be possible, because right now they are not commissioned and we are not getting the data in a manner in which it is required to be there. Now there still the remote connectivity is under establishment, and once the data starts coming, and when the vendor also at the site is also not in a position to give the data right now. Even the expert committee, the project monitoring committee also was impressing upon this point that the data should be available as early as possible. But once it is available, I don't think there should be any problem to give it. I think we could, whatever data is coming, and if he's giving a log in a manner where it can be shared, the data can be shared, that is what is there. Right now, whatever data is available in real time, but right now no logging or storage or archiving of data is there. Once that is there, should be possible.
Now, Saxena ji, I think SCADA system, they should have all the data. So you say the real.
Yeah, they should have it. So once the Mr. Ahmed, once this system is commissioned and we know the data is available in what manner, then certainly it can be shared.
Yeah. Depending on actually your need, you can tell them the SCADA system. They can.
Yes.
Yeah, they can.
Unfortunately, unfortunately, because of the stretch of the project and the COVID being there, the things not going in the smooth manner. They're not getting commissioned. The personnel within the implementing partners, the vendors changing. So I think that sort of a confidence is not there right now. But by the end of the day, I think it should be possible. Any other question which we have, or otherwise we have 10 more minutes.
Yeah, let me look. Mahesh, your hand's still up. Do you have a question? I think there's been some, Ahmed's had some questions and those have been answered in the chat. Thank you, Pravir, for doing that. Sabir, you have question? Go ahead.
Yeah, I have a small question that I think Rakshul's mentioned about it already. So the thing is that so as a part of this project, there are multiple people who have developed different algorithms for battery management system. Is it so? So one of the applications, one of the methodologies or control applications that you have shown us, is it possible to, input the custom tuned algorithms to be, in place, and then by the virtue of those, we will be able to, check the efficacy of different sets of algorithms and this and that. Is it possible? Like, does the setup allows us to do so? So, for example, we were working on that one of the test bed for voltage control applications using the RTEC. And as a part of the project, I came to understand that many of the optimization-based approaches could not be directly implemented using those RTECs. So my question was that whether the setup allows optimization algorithms to run within, and then they are able to control the batteries. That is.
Mukesh, would you like to answer before I come in?
So in the EMS, we can add any extra control algorithm because we have, as per the agreement, we can change the algorithm twice in the project throughout the project life. So we can add any extra other control algorithm in that EMS.
Yeah, Mukesh, my question is whether we can only change the parameters which are there within the control logic which we have defined, or we can give a new algorithm as well. Whether the vendor will be able to do or whether the system is capable of that or not.
So currently for the primary secondary application, we are providing on the, we have enable few parameters like charge and discharge rate and PCC rating. As we discharge rate, we are going to do, but backend we restricted it.
Sabir, does it answer your question?
It partially, but my question, my point was that we basically talk about so many optimization stuff, and then we can do this and I can do that, but it's
So
the
in
thing is
this,
that
as far
how.
as I understand, in this now, I don't think that much of optimization can be done apart from the parameter. Whatever is we have taken certain values for the SOC, for the DT loading threshold, etc. And all those can be changed about, but I am not very sure about it. One can have to check with the vendor also whether, because volt var optimization, etc. we are not doing here in this pilot. Now, but your point is that if some algorithms have been developed, can that be used or not? That is what you are trying to find out. And one will have to really check about that whether it is possible in this system or not. And number two, whether it is in the scope of the vendor to do it or not. Mukesh tells that we can change the algorithm twice in the entire life of the project. So one will have to check it really. But take your point. I understand your point.
Thank you. Thanks a lot.
Yes, there is some other hand, I think, Agalagaonkar.
Yeah, this is Yash speaking from NREL. I just wanted
Oh,
to.
yes. Hello, Yash. Yeah, please.
Yeah, good to see you all.
Yeah.
Yeah, I just want to put Subir's concern to rest. Subir, I mean, no optimization algorithm for any of the power distribution system application, including distribution volt-var optimization, is fit and forget, right? It's never fit and forget. When you implement it in DERMS or DMS, you configure the control set points, you configure the which communication set points you are going to communicate to which DERs, which voltage regulators. You will have to look at which measurements are available where on a particular feeder. So those set point configurations have to be done. Moreover, even optimization tuning has to be done when we implement it on the field for volt-var for or any other optimization. Sometimes, the feeder data itself is not that much available. So sometimes when these vendors, they have these optimization algorithms configured, what they do on the practical feeders is they even use heuristics because some of the data is not available in order to execute that optimization. So whatever is true, this is a little bit of a generic principle that one optimization algorithm in one setup which we develop cannot be directly transposed to another setup. So yeah, sorry for the longish comment, but just wanted to.
I think. Thank you. Thank you so much. So, Subir, you got some sort of a answer.
Yeah, I did. Thank you. Thanks a lot.
Thank you. Thank you. Yeah.
Thank you, Ash, as well. Thank you.
Mhm. Mm.
Excellent discussions. So thank you so much for the questions. I think we're close to winding up here. I think we would have time for one more question. So is there anybody else have one more burning question that they want to ask before we finish?
Mm.
All right. Well, thank you so much, Mr. Saxena, for a wonderful presentation and for a great discussion. And thank you to the others, TERI and other colleagues that
Yeah.
were on and answered questions as well. So it was really a team effort. And Faulty for sharing her screen. So we had the full TERI team as part of this webinar. So we appreciate that. So thanks everybody for joining. And if you have additional questions, you can reach out to Mr. Saxena or you can reach out to Sanjeev or myself and we can get you connected with the right people. But thank you so much for attending today and good night to our India colleagues and good day to our US colleagues. So thank you, everybody.
Thank you. Thank you so much. And that's why our team, I requested all of them to be here because they will know the specifics which are there. And I think it's good to learn a few important questions which have come from the colleagues from the US and even Professor Mahesh. I think we take note of this and we should be preparing ourselves accordingly to be while we move forward. So thank you, Subir. Thank you, Ahmad and Yash and everybody, and Professor Noel, of course. A big thank you to you for coordinating all this. Thanks a lot.
Thank you. And thanks to Tiffany as well for helping
Yeah,
us get all
Tiffany,
this information
yeah, she's
together.
not
So
visible, but yeah, she puts in all the effort to
behind the
bring us all
scenes.
to on this table. Yeah.
Yes.
Thank
So
you.
thank you.
Thank you. Bye bye.